Good day viewers, welcome to my YouTube channel. If you are seeing my content for the first time, make sure you like, you subscribe, you turn on the notification bell, and also share this video to your friends so that they can also learn like you. Alright, so today we'll be looking at domain and range. So what does domain means? Domain is this set of possible values of x that your function can take in without having an error, without having undefined. You have an error when you have like 1 over 0. If you have a square root, you have maybe minus, you have a negative number inside of it. So these are the kind of error we are talking about. And why is this an error? Because the whole set of the domain is just the set of the real line, which is negative infinity and positive infinity. So this is what we are looking at. This is what we are looking at for the domain of x. And then the range to the same set, negative infinity to this, just that the range is the image of the domain, just the output. For the domain you've defined, what are the outputs? What are those set of that output? So that is what the domain means. That is what the domain is asking us. So with that being said, let's look at question 1. So let's look at question 1. Question 1, we have y is equals to s squared plus 1. So what is the domain? Just ask yourself, what are the possible values s can assume in this real line? Real line is like this. You have 0, then you have negative infinity, positive infinity. So you ask yourself, is there any number you can put here on this line, and then the function will give us error? If there is no number, that becomes the whole of the set becomes the domain. So the domain of this question automatically is minus infinity to positive infinity. Okay, then let's talk about the range. There are a lot of ways to get the range. So let's look at this one. Y is equals to s squared plus 1. Let's try and express s in terms of y. We get y minus 1 is equals to s squared. So x is equals to the square root of y minus 1. So with this, we just have to do as if we are doing domain again. So what are the set of y's? What are the values of y's that will make this function to be defined? So this is a square root function. So inside this bracket now, we have to ensure that we don't have a negative value. So what we do is to have that, y minus 1 must be greater than equals to 0. So with that, y is greater than 1. So you can see that y is greater and equal to 1. You can see y can be greater and equals to 0 for this square root function. The only time this function will have a problem is when we have a negative value. So you know it's 0. Square root of 0 is 0. So that is why we include 0 in this. It is greater than equal. You don't say you don't say greater than 0. You only say greater and equals to 0. So y is greater than 1 here. So how do you write this on using set notation? So if y is greater than 1, so this is 1, and then we have infinity. So because 1 is included, you use this close interval, and then you open it here. So this open interval says infinity is not part of the set. So therefore, our range for this problem is 1, infinity. Hope you understand that. Alright, so we can also look at it using the graph. I also promised to use graph to explain it in this video. So if you use the graph to look at this question 1, we have s squared plus 1. First of all, this is a squared function called like quadratic equation. So you have x squared. So for x squared, if maybe you are dealing with y is equals to x squared, the graph is like this, s squared. But now that you are dealing with s squared plus 1, you can see that it turns at the origin. This is 0 at the origin. So for s squared plus 1, the starting point, like the point, this origin is the point at which y intercepts with the y-intercept, that is s is 0 at that point, and that is the value of y. So for this question, the y-intercept is when s is equals to 0 and then you get 1. So that is at this point. So if I'm to draw the graph, it's still the same thing as this. So you just move up like this. So what can you observe? This is 1. This is when y is equal to 1. This is when y is equal to 1. Good. So this is the values of x. Positive infinity, negative infinity. These are the values of y. So you could see that y doesn't take negative value because the down one is negative. So y only assume positive value, and you can also see that y doesn't take any number that is below 1. You get, it doesn't take value that are below 1, and y tends to infinity. It goes up, on and on to infinity. It is wide like this. It is wide. So it takes values from the upper part of y, so it's positive. Then this other side is negative values of x, but you could see that they all have a corresponding value on the y-axis. So that is why the domain is negative infinity and positive infinity. So make sure you write this. I want to remove it, then go to question 2. Now we can have space. Now looking at question 2. Question 2, we have y is equals to 1 over s squared plus 1. 1 over s squared plus 1. So you could see that this is a fraction. So for fraction, the only time you will have, let's talk about the domain. So for domain, we need to know the set of values that we make, the set of values that s can assume. So for s squared plus 1 over s squared plus 1, what is the domain? So we just have to ensure that the denominator is not 0. So as long as this denominator is not equals to 0, then we won't have an issue. So what are those values of s that will make it 0? Let's look at those values. So you equate it to 0. So let's solve for x. Yes, s squared should not be 0. Yes. So we now have minus 1. So we have s squared is not equals to minus 1. So look at it now. This is x squared. This is a squared function. There is no number you will square and then it will be equals to minus 1. It's not possible. On the real line, if you are looking at the real line from negative infinity to positive infinity, if you pick any number on this real line, there is no number you will square from this real line that will give you negative 1. It's not possible. If you say it is minus 1, minus 1 squared is 1. 1 squared is still 1. So there is no number that will give you this. So meaning that we don't have problem on the real line. So the domain of this function is automatically the whole of the real line. There's no value you put here. That every value you put in this question, you will always get an answer. Okay, so now let's look at the range. Let's look at the range. Now for the range, we can use the previous method that we did. We have 1 over s squared plus 1. If you cross multiply, you have s squared plus 1 equals to 1. Now you have s squared plus 1 is equals to 1 over y. What else? We also have s squared is equals to 1 over y minus 1. Let me work here. So s squared is equals to 1 minus y over y using the LCM. So this will now be the square root of 1 minus y over y. So now we now use this function to get the range. So what do we do? This is a square root function. So from the square roots, two things are important here. This function, because it's a square root function, it must be greater, it can be greater than equals to 0. It has to be greater, and it can be greater than equals to 0. So we just have to make sure what we have is the whole thing here could be 0. I'm not saying the denominator will be 0. So the whole of this expression, you could have 0 there. And you will get 0 if you have y is equals to 1. 1. So you get 0. So you just say y minus 1 over y is greater than or equals to 0. So let's solve. Multiply both sides by y squared. That is how you solve inequality. You don't cross multiply. You multiply by the squared of the denominator. So that gives you y minus 1 minus y greater than 0. So let's just work with y equals 0 and 1 minus y equals 0. We have 1 minus y equals 0. Y is equals to 1. Y is equals to 0. Now we need the range. We need the values of x, y, and s that will make it what is it called, greater than 0. So now if we use if we observe y in between this if y is, let's say y is less than 1 or equals to 1, when y is 1, what do we get? When y is 1, we get 1, then we get 1 into 1 minus 1, and this is equal to 0. The condition is satisfied. When y is, let's say 0.5, you get 0.5, 1 minus 0.5, so you still get a positive value. So this is valid. Now let's look at the other one. So now that we have used y is less than 1, the only thing we can use now is maybe y is greater than 0. You can also try when y is less than 0. So if y is greater than 0 now, that is let's say that should be around 0.52. So if you put that, it also satisfies the condition. So when y is greater than 0, it satisfies the condition. So the range now should be between -1 and 0. Okay, so the range is what? The set of 0 and 1. So this is your range. So make sure you write that. And okay, let me use diagram to represent this, so you could clearly see it. So we said our range, our domain is negative infinity to positive infinity. So using the aid of diagram now, our function is 1 over s squared plus 1. So we have negative infinity, positive infinity. For this function, you could see we have 0 is here, 1 is here. So we are saying that the y value cannot exceed 1. So there is a line here. So the s value we see it will approach. If you put values that are large, you see that you'll be having something close to 0. Then when you put values that are closer to 0, your answers will be getting larger, but it can't exceed 1. Also, if you come from the left to the same thing, your function will be approaching 0. Then when you approach, your function will be approaching 0 when you are coming from a bigger number of x. But then when you are now approaching 0 from x, you're approaching 0 from s, the function will be approaching 1. This is 1, so it can't exceed 1. So that is why the range is 0 and 1. Okay, so this is a thick line. Now question 3, y is equals to 1 over s squared minus 2x plus 1. So let's talk about the domain. This is a fraction, just have to ensure the denominator is not 0. It's not 0. That is s minus 1 all squared is not equals to 0. That is s is not equals to 1. So this is the real line. We have 1. S is not equals to 1. So s can go this way. It can also go this way. So it will be the union of these two parts. So that is 1 comma negative infinity union 1 comma positive infinity. So this is your domain. Okay, Now let's look at the range. Okay, so now for the range, we have y is equals to 1 over x minus 1 squared. So let's use the graph to represent this. Okay, now let's look at this. First of all, there is the graph of y is equals to 1 over x. This one is 1 over s squared. I mean, there's a graph for 1 over s squared. So this one is like this. You move from negative when you are approaching 0, because your y here will be positive because of the s squared. So it will go like this and then like this. It approaches 0, but it will never get to 0. So your graph will always approach 0. So but for this one we approach 1, because you will have undefined at s equals 0, and s minus 1 equals 0. So s equals 1. You get undefined at s equals 1, and that was what we define in our range. So our range, we said, we talk about 1. We said the function can't get to 1. It only approaches 1 from the left and also from the right. So you can do a dot like this. So the function will approach 1 from the left and 1 from the right. So what is the behavior of this function when s is coming from this negative infinity and this positive infinity? That is how we will get our image, our range. Now, as you are approaching it's just like this 1 over s squared. Now it will go up like that. So as you are coming from this negative infinity, this is a fraction. When you have a bigger number at the denominator, it will be smaller. So as you are coming from the left, the function will be approaching so it will be approaching 0 as you are coming from the left. Then when you are moving closer to 1, it will be tending to infinity continuously. So same thing from this other side too. As you are coming from the left, it will go like this. Then as you are tending towards 1, as you are approaching 1, the fraction will be getting bigger. You can compute it with your calculator. To be getting larger. So it will be approaching infinity like that. So the range now will be 0, because it's approaching 0 and it's also tending to infinity. So that is the whole range. That is the whole range. But then you could also use this. You could use what is it called? S minus. You can make your this one set of formula. I have x minus 1 squared equals to 1 over y. And then if you square both sides, you have 1 over y, the square root, 1 over y plus 1. Okay, so this form, what are the values y can take? You don't have problem with plus 1, so you are only considering this function, the square root of 1 over y. So what are the values y can take? Y must be okay, 1 over y will be greater than equals to 0. So you can multiply by y squared both sides, y squared, you just get y is greater than what? Y is greater than equals to 0. For this function, look at it. If y is 0, if you say that y is equals to 0, you see that you will have undefined here, so we have to remove that 0 point. So y is just greater than 0, which is from 0 to infinity. So that is also the range. So whichever one you understand is okay. For question 2, we have 1 over square root of x squared minus 4. For the domain, you could see that this is a square root function and it's also at the denominator. So for this square root function, you have to ensure that whatever is inside is greater than equals to 0. But because this is a fraction, so this denominator must not be 0, so you have to exclude that. So meaning we have x squared minus 4 must be strictly greater than 0. S minus 2, s plus 2 is greater than 0. So now we have s minus 2 equals 0. s minus plus 2 equals 0, s equals to 2 and s equals to minus 2. So but there's a trick here. Which of the number is the greatest here? Is 2. 2 is greater than minus 2, so it is the greater number that picks the inequality. So that would be s is greater than 2. Then the opposite side, which is the less than, will go for this other one. So x is less than minus 2. So putting that on the range, we have minus 2, we also have 2. So x is greater than 2, meaning s is approaching infinity. S is less than this, s is going to negative infinity. So that is the union of both. So this is the domain. Okay, this is the domain. So let's look at the range. Now for the range, 1 over s squared minus 4 square root, you can square both sides, get y squared is equals to 1 over s squared minus 4. S squared minus 4 over 1 over y squared, when you cross multiply it, then you can take 4 to the other side, plus 4, then this will give you 1 plus 4y squared over y squared. So what do you do next? You look for the square root. So that is 1 plus 4y squared over y squared. Okay, so how do we do this? Okay, we can do like this. We can say okay, we can split the roots. Okay, then we get square root of y plus y squared, 4y squared. We only have to make sure we can, when you split the roots, you see what you will get, 4y squared over y. So you just have to make sure that this, then for this is x now, so to get the range, y shouldn't be 0. Do you get? So the possible value is that we can have minus infinity to 0 and union 0 to positive infinity. But looking at our question is 1 over the square root of s squared minus 4. If you look at this function can be negative. Like the output can give you a negative value. You can't have a negative value for y. Like the range can cover negative value. This square root that is here is always positive. So your functions, you can only get a positive value. So it means that the range will be 0 to infinity. Do you get? Now you can, for better understanding, if you look at the diagram, we said the domain is the set of negative infinity to 2 union 2 to infinity. So if you look at the range, the diagram, we have the graph doesn't touch 2, so it only approaches, look at it, minus 2 to 2. So we have all these values of x and these values of x. So these are the parts we have s values. So what are the values of the function when you have a, like, all this minus infinity? Like you have like minus 100, minus 1000. When you compute it, you see that you are approaching 0. But when you are now getting, when the numbers you are computing is lower, it's not like 0.5, you see that your function will be getting larger and larger. So same thing on this other side too. As you are coming from the left, to be lower, then as you are moving closer to 2, your function will increase. The function will increase. So that is why it is. So if you look at the range of x, y now, y is 0 here, then approaching infinity on this part. So the range is 0 to infinity. Alright, so write that. Let's move to the last question. Y is equals to the square root of s squared minus 5s plus 6. Okay, so this is a squared function. Let's talk about the domain. you can try it out and see what you will get. So for the domain now, you have to ensure that whatever is inside that root is greater than or equals to 0. So if you solve this, the factors are s minus 2, s minus 3 greater than 0. So from here, I've told us just equate this to equals to first. You get this. So the bigger number goes with this inequality given. So the bigger number here is 3. So it will be s is greater than 3. It can't be 3. S is greater than 3. And also, yes, it can be 3. S is greater than 3. And then you get s is less than 2. Yeah, can be equal to. Both can be equal. If you let's check, if s is equal to 2, you get 2 minus 2, then 2 minus 3. This is 0 times minus 1, which is actually 0. So that is why I'm saying it is both, right? So the domain of this function will be, since s is greater than or equals to 3, that will be 3 to infinity. 3 is included, and this one will be 2 to negative infinity. 2 is also included. Okay, so it will be the union of both of them. So this is your domain. You have the real line, you have 2, you have 3. One is going this way, s is less than, is going this way. The other one is greater, so it's going this way, like this. So it is the union of both that would form the domain. Now let's look at the range. Y is equals to the square root of x squared minus 5x plus 6. Let's look at the range. So to get the range now, what do? We look at the possible values of y. The possible values of y. Let's use the graph method to solve it. So graphically, let's see how it will behave graphically. We have 2, and then we have 3. So our graph can touch 2, you can rule a straight line, and you can also touch 3. Now, there's a way we draw when y is equals to maybe like square root of x. There's a way we draw it. So it is something like this. When x is 0, so it goes like this. This is how you draw it. So x is only positive. You can see x is only positive. So that is why it's going like this. Okay, so you don't have negative values of y. So this is how it will look like. Then for this one, if you approach 2, you can approach 2 from the left. You know, we said minus infinity to 2. So from this left now, from all this negative infinity to 2, how does it behave? You can see that your function will go, as you are far away from 2, like all this negative infinity, your function will be very large. Then as you are moving closer to 2, it will be approaching, see, it will approach 2 like this. That is how it will come. So same thing for 3. As you start from 3, 3 is 0 now. 3 is 0. 3 is 0. When you put 3 here, you get 0 for y. So it will start from that 3. Then as you move, it will go on and on. So that is it. So you could see the the range. That's what I want us to see. So what is the range? The range of y now will be, you could see that y only assume positive values. So that is what you should observe. So y only assumes positive value. It moves from this straight line now. This line is your y coordinates. We have, this is positive infinity, this is 0. So all this drawing that I did is on the y-axis, is on the positive part of y-axis. So it is between 0 and close interval of 0 and infinity, because 0 is part of it. So this is your range. Thank you very much. Make sure you share this video, and see you in the next video.